In this video, I'm going over the questions from the 2021 first semester exam for the Preaice physics class. Question 1. A water wave in a shallow tank passes through a gap in a barrier. What happens to the speed and what happens to the wavelength of the wave as it passes through the gap? Diffraction occurs when a wave passes through an edge or through a narrow gap. In this case, is a gap. So from your notes, diffraction is referred to the bending of waves as a result of passing through an opening and also around a corner. Wavelength, frequency, and speed do not change, only its amplitude. So here we have just two options, speed and wavelength. So speed remains the same and the wavelength also remains the same. So the correct answer is D. Question 2. The diagram shows a wave, which labeled distance is the wavelength. So A, option A, is the amplitude, is the vertical distance between the equilibrium line to the crest. B here is the horizontal distance between just one section of a complete wave. So B is not the correct answer either. C is the horizontal distance between this point and this point. As you see, one complete cycle. So C is the correct answer. D is the vertical distance with 2 times of the amplitude from the equilibrium line to the crest or the equilibrium line to the trough. Question 3. The diagram shows water waves that move more slowly after passing into shallow water. Which diagram shows what happens to the waves? Let me show you your notes before answering this question. So here is a diagram showing the deep water to shallow water. So the median is the same, which is water, but the water level has changed. So what happens to the wave when it moves from deep to shallow? Is going to slow down. So because it's going to slow down, it's going to refract toward the normal line, and the wavelength is going to be smaller than the wavelength from the deep water. So the wavelength decreases and the speed of the wave also decreases. Now let me find an option that looks like this. So option A, from deep to shallow, there is no bending, so this is not the correct answer. Option B is bending, but the wavelength here is greater than the wavelength at the deep water section. This is also not the answer. Option C. So here the wavelength is smaller than from the deep water and is bending towards the normal. The normal is right here, so is slowing down, is bending, and the wavelength is smaller. So C looks like the right answer. Option D is showing the wavelength is smaller, which is correct, but there is no bending. So there is no, the speed remains the same here. So that's not correct. So that's the right answer. Question 4. What is the number of wavefronts per second that pass a fixed point? Option A, the amplitude of a wave. So the amplitude is the vertical distance between the rest line to the crest. So this is nothing to do with the number of wavefronts per second. The frequency of the wave. So what is frequency? Is the number of cycles per second. So here in this question, cycles has been replaced with the word wavefronts, which is the same. So option B is correct. Let me look option C, the speed of the wave. So the speed of the wave is the product of its wavelength times frequency. No, so this is false. And the last one, the wavelength of the wave. The wavelength is the horizontal distance of one complete cycle. Correct answer is B. Question 5. A water wave passes into a region where the wave travels more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength of the wave? So this question sounds like the water waves when moves from deep to shallow water. Why? Because the question states that the wave travels more slowly. In this case, what happened to the frequency and wavelength? I'm going to bring back the picture. So here is the water wave comes from deep water to shallow water. So the frequency here remains the same, but the speed decreases. So if you see on your notes, we have everything there. So the wavelength decreases. So the question is asking what happens to the frequency and wavelength of this water wave. Answering this question, I'm going to bring back this diagram from deep to shallow water. So here we have on your notes that the wavelength decreases and the frequency remains the same. So frequency remains the same and the wavelength decreases. So option C is the correct. Question 6. Light travels at a speed 2 × 10⁸ meters per second in a glass block. In the glass, the wavelength of the light is 4 × 10⁻⁷ meter. What is the frequency of the light? To answer this question, you need the formula for the speed of a wave. The speed of a wave is the wavelength times the frequency. So it's asking for the frequency. So I can rearrange this formula is V over lambda. Now, the speed of the wave in the glass block is 2 × 10⁸, and the wavelength is 4 × 10⁻⁷. -7. Let's bring a calculator. So this is 2EE8 divided by 4EE -7, and that's the answer. The frequency is 5 × 10⁻⁴ hertz. Option D. Question 7. What row correctly defines a type of wave and gives a correct example? Option A. A longitudinal wave is parallel to the direction of the wave travel. Correct. Example, radio waves? No. Radio waves are part of the electromagnetic spectrum, so this is not a longitudinal wave. Radio waves are transverse wave, so this is incorrect. Next, B, longitudinal, perpendicular to the direction of the wave? No, it's not perpendicular. Longitudinal or parallel with the direction of the wave. The light waves being a example, not really. Light waves, they are electromagnetic waves, which are transverse wave. Now, transverse, parallel to the direction of the wave? No, it's not. It's perpendicular. And light wave is an example? Yes. The last one, transverse, parallel to the directions of the wave travel? Correct. Is an example radio waves? Yes. So the correct answer is D.